stresses acting on an infinitesimal soil element are shown in the figure with sigma z greater than sigma x. So this sigma z is greater than sigma x. The major and minor principal stresses sigma 1 and sigma 3 respectively. Considering the compressive stresses as positive, all are positive here, compressive normal stresses, which one of the if you consider compressive stresses as positive, which one of the following expressions, that means these four, correctly represents, one of them will be correctly representing angle between the major principal stress plane and the horizontal plane. See, the question is about, so when sigma 1 and sigma 3 are major and minor principal stresses and sigma z and sigma x are these stresses in which sigma z is more and tau zx is the shear stress. So when all of them are denoted by like that, considering the compressive stresses as positive, which one of the following expressions, one of them will be correctly representing the angle between major principal stress plane and the horizontal plane. Okay, so to understand the angle between two planes, we can draw the Mohr circle by which we can understand it. Anyway, so let us start drawing the Mohr circle, taking all these stress conditions of this element. Let us reproduce the same diagram in the next slide. Sorry. Okay. This is tau zx and this is sigma z, this is sigma x, isn't it, where sigma z is greater than. Okay, now this is sigma x, tau zx and sigma z. Let us change the color so that we can understand. So let us draw the Mohr circle for this. See, to draw the Mohr circle, to draw Mohr circle, what do we need? We need 2 points and those should be ends of diameter. Okay, so those two should be ends of diameter. Then those 2 points are what actually? What do they represent? Points represent sigma 1 comma tau 1, let us say, sigma I comma tau I and sigma j comma tau j. These two are the 2 points, let us say. These two are 2 points, 1.1, 0.2. Okay, and these 2 points should be on the perpendicular planes. Then you can draw those. If these 2 points are the stresses which are representing the stresses on the perpendicular planes, then these will become ends of the diameter. Now, so anyway, these two are perpendicular. Okay, then you have the 2 points. One is what? Sigma x comma tau zx and sigma z comma tau zx. But here, which is negative? See, here this couple is making anti-clockwise. Okay, whereas these two are making anti-clockwise. So one of them should be negative. One of them, like suppose if you take anyway sigma z and sigma, these two are positive. Okay, these two are positive. Why? That is mentioned, compressive. So positive. Then what about these two? These two, anything you can consider anti-clock positive or clockwise positive. Let us consider anti-clockwise is positive. Okay, so anti-clock is positive and clockwise is negative. Let us consider these two. Now how the points will be changing now? Point 1 will become, let us say this one, sigma x is lesser, sigma x comma clockwise is negative, so minus tau zx. So point 2 will be sigma z comma tau zx. Let us draw. Okay, what I'll do, I'll take point 1 first. Sorry, I'll go to the new slide. Let me draw bigger one. Okay, what are those points? Point 1, point 2. Point 1 is sigma x minus tau zx, sigma z plus tau zx, but this magnitude is same, this tau zx is same. Anyway, now this is tau, this is sigma, and sigma z is greater than sigma x, so sigma is this side, sigma z is this side. Okay, so let us consider this is sigma x and this is sigma z, because sigma according to this condition sigma x is less than, and now both are tau zx only. So if it is negative, it will be downward somewhere here. Let us say, let us consider this is, so this will become, this is tau zx, so same distance, this is positive tau zx, this is negative tau zx. So in positive tau zx, this is 0.2, this is 0.1, right? Now, sorry, see, these two are the points on the perpendicular planes. That is the reason why point 1 and point 2 will become ends of the diameter. They are ends of the diameter. Now we came to know that. And next, wherever it is cutting this x-axis, as this height is same, see, this is tau zx, this is also tau zx. Okay, height is same, and you know that this angle is also same, this angle is also same, because this is equal to this, right? That's the reason why this will become equal to this, and there is one side they are same, and this is radius, because you see the midpoint of these 2 points. What is the midpoint? x1 plus x2 by 2, y1 plus y2 by 2 is the midpoint of p1 and p2. What is x1? p1 is sigma x plus sigma z by 2, and tau zx minus tau zx by 2. So this is 0. So wherever y coordinate is 0, that is center. Sorry, that is the midpoint. So midpoint is nothing but the center. So here y coordinate is 0 because it is on the x axis. So by default the midpoint will become the center, and that is coinciding with this, the intersection of the line and this. So this is sigma x plus, this is sigma x plus sigma z by 2. Anyway, so you know the center, you know the end points, you can draw the circle, right? You can complete the circle. How do you complete the circle? Okay, so this is circle, right? So I'm not completing it fully now. Let us change the color. Drawing the element, so I'll draw the element. Given element is sigma z tau z sigma x tau z. Here we know that major and minor principal stresses are nothing but the stresses on the plane where shear stress is 0. That means wherever the point, all the points on the Mohr circle, all the points on the Mohr circle represent what? Every point represent the combination of stresses on any plane on the given element. Okay, now this is also stress combination, this point is also another stress combination. So let us take this point on the Mohr circle. There y coordinate is 0, that means tau is 0. Here also we can, there is y coordinate 0. So these two stresses, these two normal stresses, the x coordinate of these, they should become principal stresses because shear stress is 0. Anyway, sigma 1 and sigma 3 are the principal stresses that is given in the question. So sigma 3 is minimum, sigma 1 is maximum, major principal stress, and this is minor principal stress. Okay, now what is asked in the question is about the angle between major principal stress plane, that means major principal plane and horizontal plane Okay, what is horizontal plane here? This is horizontal plane, this is horizontal plane. Here first we will draw the pole. After drawing the pole, we can understand what is horizontal plane, what is major principal plane. How to draw the pole? First take the known stresses. Where is sigma z is acting? Sigma z is acting on the horizontal plane, See, this is sigma x, the point, this is point of sigma z and tau zx, and this is the point of sigma x tau zx, so minus. Okay, so sigma z, this point means it is acting on horizontal plane, so draw a horizontal line. Okay, so draw a horizontal line through this. Okay, I am drawing a horizontal line through sigma z point. And where is sigma zx, sigma x? sigma x is acting on vertical plane. So sigma x point here, you draw vertical line along this. Okay, so I will draw vertical line along this. Okay, so the point of intersection of these two lines which I have drawn, that will become pole. This is pole. Okay, this is pole. This is how you should draw the pole. Okay, pole. Now from the pole, whichever line you draw, that is the real plane. So this is horizontal plane. If you draw horizontal line from this pole, that will become horizontal plane. Okay, now the question is about what? Question is about angle between horizontal plane and major principal plane. How to find out major principal plane? You have to join the pole and the major principal stress. So the line joining pole and the major principal stress, that is major principal plane. So I will join them. Okay, so I have joined them. So this is major principal plane. Now this is major principal plane, this one, and this is horizontal plane, because I can draw horizontal line, that will become horizontal plane. So that this angle I should find out. Okay, how to find out that angle? So let me erase unnecessary things here like this. Okay, but I can draw them inside. Okay, this point is actually P2 point representing sigma x comma tau zx. Anyway, now what I do to find out this angle, you know the height of the this height from here to here, from here to here. So I'll extend this triangle, that's it. Okay, I'll extend this triangle and I'll draw a vertical line from, okay, I'll draw a vertical line from sigma 1, and horizontal line I am extending. This will become 90 degrees. Okay, and I know this height. This height is equal to, this height is equal to tau zx, right? This height is equal to tau zx. This new point of intersection of this one, I'll give, let us say, S, and this is major principal plane. So this major principal, so I'll give this as M. Let us say this is M, this is S, and let us say this is P. So now triangle MSP. So here in triangle MSP, sum of all the angles should be 180. So you know this is 90. You should know this is, let us say this is alpha, which we have to find out. And if you know this side, okay, from P to S, let us just find out what is tan alpha in this. Okay, I'll just erase this. Okay, I'm erasing this. Okay, in this triangle MSP, tan alpha is opposite side MS divided by SP. Okay, right? Tan alpha is MS by SP. What is MS? Okay, I'll draw this. I am doing the calculations here so that you will understand. Okay, in this box, what is tan alpha? MS by SP. Okay, what is MS? What is MS? MS is height, that is tau zx. Tau zx. And what is SP? SP, here to here. See, S, x coordinate is sigma 1, and P, x coordinate is sigma x. So SP will become sigma 1 minus sigma x, right? Distance between S and P. Now tan alpha equal to ms tau z x divided by sigma 1 minus sigma x. Therefore alpha equal to tan inverse of tau zx by sigma 1 minus sigma x. So this is the angle between horizontal plane and MPP, major principal plane. So let us see, tau zx minus divided by sigma 1 minus sigma x. Okay, tau zx by sigma 1 minus sigma x. So A will be the answer.